If I remember right, this is a fairly short one. So we're going to talk about beverage antennas again and some other specialized receiving antennas, radio direction finding, and long wire. The beverage needs to be one or more wavelengths long. It's directional, but it doesn't have gain compared to a dipole. But usually at the lower bands where they typically use these, you don't care about gain because of the atmospheric noise. So you're more interested in directionality than gain. They use the termination resistor, and you can adjust that value to adjust what the SWR is over a broad frequency range. So depending what that is will affect what your SWR is at different frequencies.
What determines that value, that adjustments?
I'm sure there's a formula, but I don't know what it is. Typically, you see it like this with a 450 ohm, but apparently it can be other values. And they have a lot of counterpoises on these things too. So when you build a beverage, which of the following factors should be included in the design to achieve good performance at the desired frequency? One or more wavelengths long. So the longer it is, the more directional it is. What's the function of a beverage antenna's termination resistor? What in Brevard? Brevard.
What is the answer?
To absorb
signals from the reverse direction. To absorb, okay.
What indicates the correct value of terminating resistance for a beverage antenna? Well, it's a generic answer. I still don't have a clue how you calculate it. I guess one way would be to model it and then play with different termination resistors and see what you like best.
Delta?
Yeah, it was delta.
Yeah.
Which is generally true for low band 160 and 80 meter receiving antennas. A pennant antenna. You ever seen a pennant? Me either. I thought about trying to make one, but I'd have to do it for UHF because of the size. It's a small vertically oriented antenna. This is vertically polarized. It's shaped like a pennant, and I guess in some cases they claim it's rotatable because it's on a vertical shaft. So I guess you could have it so you can rotate it around. I think you can do that definitely at high frequency where it's small enough. It has a termination resistor. It seems like all these receiving antennas do that. If it's square, they call it a flag. If it's kind of triangular or trapezoidal, they call it a pennant. I don't know. I think they kind of work the same regardless. So it's got a 16-to-1 transformer. So you're looking into a fairly high impedance if you imagine that 50 ohms. What type of radiation pattern is created by a single turn terminated loop, such as a pennant antenna? I don't think we talked about that.
Yeah, that's when I was thinking, but I'm thinking, where'd it come up with that? We'll just guess. Oh.
Oh, I left that out. Well, so what do you think it's, what do you think it's going to be? I doubt that it's going to be a cardioid. I don't think it's going to be hyperbolic. Bidirectional or omnidirectional? You think it's bidirectional? You think it's bidirectional?
It's a loop, so. It's not being directional.
Oh, it is cardioid. How about that?
I was wondering if it was like folded back.
Yeah, I don't know.
I guess you don't have the information.
I have to go add a chart to that one.
So if we get that on the test, we can tell them that it's your fault that we missed it.
Yeah.
Yeah.
Except you won't know which one you missed.
Huh?
Yeah, we can't tell you that.
They can't, or they won't, or don't.
Yes. Well, the reason is if you do an online test, you can find out exactly what you missed. If you do it in person, we have a limited number of booklets. So if we told you which ones you missed, okay, you'd have information you could pass. I mean, I'm sure you wouldn't do it, but you could pass it to other people and you'd eventually know what was on the test, which ones were which. Even though they mix up the answers, they're printed booklets. So, I mean, they're fixed and there's like 10 or 12. Actually, Gary, I don't think he has that many. That's why they don't tell you. If you do it online, they actually send you, you can get your answer sheet.
Well,
But I'm sure you'll remember that. Let's see. For receivers, we have the receiving directivity factor, which is just the ratio of forward to average gain.
what's the average gain? Average gain of what?
For the radiation pattern, I guess it would be the area under the sort of under the curve. In other words, if it's omnidirectional, the average gain is going to be the radius of that circle. If it's a directional, you've got some sort of perturbation of that circle, like a cardioid or a lobe out here, or two lobes. So exactly how you figure the average gain, I'm not sure, but it's going to be less than what you're going to have as a directional antenna. So it's that difference between if it was a isotropic versus directional, I guess. So a pennant has an RDF of 7.5. So it means its forward gain is 7.5 times its average gain. Sounds good. I don't know. And if it's a one wavelength beverage antenna, it's 8.6. That's why I think I could only build one if you're talking maybe UHF. Because, or I guess VHF, you still could do it.
This is a bogus subject.
Why?
But they don't give you anything to reference it to. They said it's better than blah, 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 but they don't tell you what blah, blah, blah
Yeah,
is.
well, they just had to throw a bunch of stuff in. Here's all kinds of directivity factors for different antennas and configurations, from small loops, which is 4. You can get 3 broadside 80 to 900 foot beverages and get 14 to 16 dB. Basically, size matters. So what is receiving directivity factor? All right. Radio direction finding. There was some question about doing a fox hunt. Did that ever come back up? No.
Well, the guy keeps asking about it and we keep ignoring it.
Well, I think it'd be
I
fun.
think it'd be evolved. I don't have anything to do it with, but I would.
Well, you're part of the deal is you're supposed to build your fox hunt antenna.
In California, they do one like almost every day.
Well, the
VHF
government's doing
ones,
that.
VHF ones, you can go any day you want.
Yeah, there's a lot of things for building little, like 3, 4 element Yagis. If you're doing it like 70 centimeters, they're not very big.
I used to chase 121.5.
What?
The ELTs, emergency locator transmitters, airplanes, they go off all the time.
Yeah.
You gotta go find them, and turn them off. Great fun.
Okay, one of the things is wire loop antennas. Kind of like back in the old days when your little AM tabletop radio had a wire loop in the back as the antenna with multiple turns. And you use the multiple turns to increase the output voltage from the antenna. So what challenge is presented by a small wire loop antenna for direction finding?
Alpha.
Yeah, we talked about that a couple times. How can the output voltage of a multi-turn receiving loop be increased? One of the improvements you can do for a loop is to put a shield around the loop, which somehow eliminates some of the capacitive coupling. I guess it's kind of like the effect of a screen grid and a vacuum tube to reduce the capacitance. I guess it's a similar type thing. So you can get better nulls that way. And here's one of the shielded loops where the one thing I didn't understand about this, they talk about use a silver plated copper wire of 14 gauge with circular distances against the wall. I have no idea what that means, but I don't see any way to keep it separated at an equal distance from the copper tube that it's in. And I would question, why don't you just make it out of a piece of coax?
And what's up at the top? Is it?
Just a plastic box to insulate the outer shield. So it's connected together at the bottom, but it's open at the top. So the shield itself is like a half wave dipole. But the wire loop goes all the way around. It's a continuous loop. So what's an advantage of placing a grounded electrostatic field around a small loop direction finding antenna? Bravo. Sometimes they'll add a sense antenna. So it'll modify the pattern of the antenna so you can get a null in one direction and not two. I guess you kind of basically make it into a cardioid. So what's the function of a sense antenna? Another way is to actually build one with a cardioid pattern. So you build your array of two dipoles. Do you remember the presentation we had on the direction finding, and the guy showed his Kraken with the array of 6 antennas on top of the car?
Oh, yeah.
That was an expensive outfit. Oops. So what feature of a cardioid makes it useful?
Yeah, the real sharp.
It has very sharp.
Doesn't on the back.
But the key is a single sharp null.
Oh,
A single sharp null. Because you could have a pattern and have 2 sharp nulls, 180 out. Okay, so beverage was a wavelength or more long, a termination resistor, so it absorbs reverse direction signals, which makes it unidirectional. You can play with the termination resistor to vary the SWR, but I don't know how. And it doesn't have any gain over a dipole. You don't care anyway, because if you're using this, and they're normally intended for low band operation where you got a lot of noise. Yes.
the termination resistor absorbs signals from the reverse direction,
That's what it says.
so you would select that value to reject the signals that you don't want. But you also select that value to.
Well, you would want to keep the SWR for the frequencies you want as low as possible.
Yeah. So hopefully it's the same resistance.
Well, there's only one, I think.
Well, you got the resistance to get the SWR down where you want it, and then you got the resistance to reject the frequency.
Yeah, but it's the same resistor.
But it could be 2 different values, is what I'm saying.
But it can only be one at a time. You have to pick one.
It's doing 2 separate functions.
True, but it's like most things, it's going to be a compromise.
Okay.
Everything is a compromise. We talked about RDF, wire loops, which have a bidirectional null. Use multiple turns to get higher output voltage. Put a shield around it, improves the nulls. The sense antenna can modify the pattern so you can reduce it to 1 null. Cardioid gives you the best pattern. And stop recording. Well,